And now we have Bob. He can tell you his tale of woe, what it took to get Octave going.
Well, first off, why Octave?
It's free.
Yeah. Why, JJ, don't you have MATLAB?
Somebody buy it for me, I'll have it.
How much is it?
About 6,000.
Right. Unless you get the student version, which you're going to convince me you're a student still. That's only 2,000. 2,000. So MATLAB and Octave are kind of similar, but not exactly. But the motivation here is it's free.
How about Scilab? Is that similar?
I don't know. But we're going to concentrate on MATLAB because that's what JJ uses. And if you want the script that he's so kindly provided that allows you to look at your own audio and make these plots for yourself, you need Octave.
Or MATLAB.
Or MATLAB.
You have to change the plotting in MATLAB, but then you have a lot prettier plots.
But how many here are familiar with MATLAB? Actually use it. Okay, there's a few. How about Octave? A few. And the rest of you then might want to try this, but you're probably not going to want to start from scratch. You're going to want to just say, can I get Octave running on my system? Can I download JJ's script? Can I edit it to point to the file I want to analyze, and then just press go and have it happen? Okay, in theory that sounds nice, but in practice, Octave has some quirks. And so we're going to talk about that. Okay, so this is going to be a real short presentation. It's nothing too hard about it. In fact, this is on the website so you can get it. You don't have to memorize anything. But there's a couple of things in here you're going to want to have. And so we're going to talk about the version, the permissions during the install. That's kind of important. The installation setup, and then verifying you've actually got what you get it done. So, very important. JJ's using version 3.2.4. I suggest you use version 3.2.4. As I went through different versions, I discovered that there was some mismatch between the sizes of the variables that are passed from sub-packages to major packages inside that screw up, or that the precedence of operators, at the more advanced level of operators, for people who understand what that is, would change. And so you might end up with, yes?
Before you get too far, is this Linux, Windows, Macintosh,
This one's Windows.
Unix?
This is Windows that I'm mentioning here, but Octave is made for any of the systems. But I'm going to give you the specific instructions on finding the Windows installation version. It's the pickiest of them all. And it's the biggest pain in the ass. So,
Anyone knows.
but the one thing I would mention is no matter which operating system you want to work with, use version 3.2.4. It's the same one that JJ's got. It's stable. You can press the button and get an answer, and it will give you the same kind of results that JJ.
And the reason I use that is because the signal processing package worked properly on 3.2.4.
Mm-hmm.
You may infer from that an exclusion for some of the other versions.
So that's point number one. Point number two is where to find it. This link, which is in the downloadable PowerPoint, just go there, click on that, and it will take you here. And when you get to this page, this is the thing you want to download. For those of you who want to do a Windows install, pick this one that the green arrow is pointing to. Download that package. Once you've downloaded it, wherever you've decided to put it in your downloads, install it as administrator. If you don't do that, and you probably want to turn off the browser, after you scan it, make sure that you don't have an infected version, which this site's pretty good. But I do that as practice anyway. Just scan it and make sure that there isn't any findings that came along with it. You want to turn off the virus checkers and run as an administrator so that you won't have some portions of the packages that get installed later get refused because they wanted to put something in a protected area of the Windows file system and weren't allowed to do it. So that's a step that you've got to make sure you get through. Then when you do the install, these are the packages JJ has selected, installed. Do the same ones and you won't have any trouble. Miss a couple, you'll have trouble. So this is the list, and where you use this list is when you're at this point in the installation of Octave. There's where you get to check them. You have that list on the previous page, just go, and they're in order, just go down and check all of them, and then hit next. And when you're done, and you run Octave for the very first time, just type VER, you'll get this information. Make sure that you have the same numbers in this version column as what's on this one, and you'll have the same install as JJ. Then all you have to do is decide where you're going to put your workspace under Octave someplace, copy a script in there, bring in your file that you want, put it in there, and go.
And I'll show you how to edit the files so that you can put in whatever your own file are. You know, because the file name is included in the script, so you'll have to edit the file, for which you probably also want to get Gavin, because you have to edit a text file. You do not want to wind up getting RTF garbage.
But Notepad will work if you just, Notepad, don't use WordPad, don't use Word, use Notepad, and it won't add garbage that will screw up the script. So it seems relatively simple. I took a few tangents and paid for it. And then the last thing I'm going to leave you with is a word of wisdom. Once you've booted, run Octave from a fresh boot. Start, boot, and make sure that your page file in your Windows system is not fragmented, and that you don't fragment your memory, because as JJ was mentioning earlier, there's some really large array manipulations going on here as the blocks are moving along. And on a Core i5 processor running 1.6 gigahertz with 4 gig of memory, you should be able to complete one of these, a 4-minute or less thing, in a minute or two. You let your system get loaded up with other processes, you let the memory get fragmented. That's an operating system detail that Windows has as a feature, I suppose. And if you, heaven forbid, have to hit the page file and let the page file get fragmented, what he was describing earlier, you start up and go away and come back, maybe the next day it's done. So you have your choice between getting your results in a day or two or in less than a couple of minutes. Do it from a fresh.
And
so,
observation, after you run it for a while, close Octave and start over. That will free a whole lot of memory, and Octave is a memory pig.
And GNU plot adds to it on top of that, which he's using inside.
Yes, GNU plot is a disaster, but it's free.
Hey Bob, hold off. You had a question back here?
Yeah, I was just wondering if Notepad++ would be fine.
That I don't know. I haven't tried it, so I don't know if it has
Should be.
garbage.
Yeah.
Bob?
What version of Windows are you running?
This was Windows 7, but it should work in
I've done
anything.
this in XP and 7. And the thing is, in 7, you don't actually have to turn the virus the virus stuff off as long as you run an administrator. In XP, you'll have to turn the virus stuff off. But if you're running XP, get rid of it.
Well, you know, I got this far and I did it, and it came up saying error, couldn't find idiot wave.
That's because the file name, you have to change the file name in the program to match whatever your wave file is. I'll show you here.
And you need to
didn't
run.
include the
You
wave
need
file?
to run the.
So you have to find your own wave file.
You have to change the script. There's a thing that says file name equals blah blah blah. You have to change that to your file name.
Okay.
Change your file.
And it helps to have the file that you're going to analyze. The file you're going to analyze in the same directory as the script that you're going to.
You don't have to, but it's a whole lot easier.
Okay, that's what I didn't do. I opened it up in Notepad and I looked at it, gave me all the information, and there it was.
Okay, so I will show you the script and where to edit it here. See this? This is the file name. You need to leave the .wave, but you change this. The name of this file name is 03. So you change this to your file name. So say if I wanted to do the...
JJ, can you make that bigger?
Nope. Sorry.
01.wave? You can't
Well,
change the font?
you change it to whatever the name of your file is.
Oh, I see.
If your file's name's Fred, you change it to Fred.wave.
I didn't know whether to take it personal. You call me an idiot.
No. What I can do, say I'll change this to, I don't know, I'll change it to 07. Okay. And then I save the file. I'll put that away. And now I'll show you I'll play for you what file 7 is. How's that? Yes, that came. Can you guess where that came from? Straight out of what movie? That movie was a blast. So now I'm going to re-edit this to be 3. And now I'll show you how this goes down. First, you have to go to the right directory. And I forget how this is. Okay. CD. Then all you do is that, and now you wait. And if you're standing up here, you notice suddenly my CPU fan started to go a lot faster. Sorry, I can't turn up the size.
While we're waiting, what are you using as your source material for all of these?
This is just all taken right off a CD. It's all taken right off a CD. Fortunately, it isn't very communicative. I don't put out intermediate block numbers because that slows it down and actually fragments the I/O stack, which is another pain in the neck. But this will, when it's done, it'll print out a bunch of stuff and then we'll put up a graph.
So I did add TikTok to it so I could see how long the script took to run.
Yeah.
The script only takes about 15 seconds.
Yeah.
But then the plot takes another 45.
Yeah. Well, this is a slow old machine, too.
Program that calls you an idiot, you know.
Well, well, you know, it's the E_1D10T, right? Yeah. Should feel the nice heat coming right here, right now.
You get that warm, fuzzy feeling.
It's getting this warmth right out of the side of the computer. I'm going to move this over a little bit. And there, that cooled it down a little. And I know this works on this machine because I did all of the FFT workshop on this machine. So I know this will run. Eventually.
How long do you expect this to take?
What?
How long do you expect this to take?
Well, I don't know because I've been running.
This is going to be the 2-minute one or the 2-day one?
This should be less than 2 or 3 minutes, but I haven't run it on. I haven't run this script on this machine, so I don't know.
Lawrence, how long do we have this room?
Well, if it doesn't finish pretty soon, I'm going to put.
PowerPoint running?
What? No, I shut down PowerPoint. But it is in fact running. It is in fact running properly. I can see that from the.
And this is where that program that I sent you the license for, you could be watching it, doing its thing, and saying, "Oh, look at that," and see if it's struggling or not struggling.
As you can see, it's chucking along.
Hit the performance tab there, and more graphically, you can see what's happening. That one.
As you can see, it's basically parked in one CPU and running. Aha! When you see those jumps, yes, it's not having a memory problem now.
There we go.
There we go. Now, and now it's plotting. This is the other. Oh, in fact, it has plot ed, except it has plot ed on the wrong screen. And that last one will come up in a minute.
That's what we heard.
There's a couple of missing codes. Look at that. Yeah, look at those missing codes. My guess is that that's just somebody did a very slight gain scaling at the end, because that's what it looks like when you do a gain scaling, and you didn't dither.
It must be an old conversion then.
It's an old converter, yeah.
Maybe. Well,
You know, I don't see how that would happen with anything from today.
No, this wouldn't happen with Sigma Deltas, but that's like a
What
ladder
is
structure
the
or flash
flipping
converter.
peaks of the?
there we go.
What are,
As you can see, it's a little compressed, but we're not shocked. Not horribly compressed, and actually has some dynamics. But we knew it. We already knew that, but see, you can see here what's going on. And so that's how you run it. Did that help?
Yeah.
Yeah, that was very cool.
And if you're running this on the desktop, it's a lot faster. This really bottlenecks the cache on a little processor. Yeah?
So what kind of file is this grabs open?
Yeah, that's right.
They did some, what?
It's good.
Graphical display.
That's running, that's GNU plot. Yeah. And unfortunately, the only way to copy that is to do screen copy and dump it into a photo editor. There's no way to dump it out. Or you can get a PNG, but whatever, you know, there's no polite way to get these. Unlike, you know, that's a nice thing. In MATLAB, I can tell it to give me a JPEG. Bless you.
But you could dump out the data and run it in Excel or something.
Yeah, you can do that. I mean, once you got to the point where it does the spits out the row of numbers, you can just write the data into a file. If I had MATLAB, I would be doing that. So, what I find interesting here is this and this right at 16K. There's a hole in the converter right at 16K. And
there's also some out towards the edge.
well, these, yeah, but this you can expect because you know you're getting money less, and you're getting a lot of clipping again here. But with Spirit in the Sky, I'm not so floored given the state of the. If you've ever looked at the waveform on it, I'm not terribly shocked because I think if you reduce the gain, you just see those peaks move in. So that is how it works. And if you want to do some other file, you can always do different files. You just have to edit the script.
JJ, have you given thought on this algorithm running in a real time on a meter?
It would work. You could do it real time because the stuff that's slowing it down here is not necessary, if you understand what I mean. You could certainly do this in real time in a meter if you know how to program a plug-in, and I don't. But
So it would be basically a meter that would measure your ALUs? Is that what you're saying?
well, you can do a lot of different things.
What was the distance graph that this one does?
It does a distance graph, and then it does a histogram of the distances.
What do you mean by distance?
The distance is the block-to-block change in loudness.
Okay.
The normalized block-to-block change. So, and lo and behold, what do you suddenly notice on the CPU meter? Yes. How long is it? Oh, this is long. This is going to take forever. This is going to be take about twice as long. That's a lot of blocks.
You need to make it a multi-thread.
Well, you could. The thing is if you're not doing this is an interpreted language. This really heavily overstates the complexity of the problem here.
Hey, JJ, have you ever benchmarked Octave against MATLAB?
Oh, Octave is like way slower than MATLAB. Way slower than MATLAB.
Way, twice, 3 times?
It depends on what you're doing. The histogram function in particular is in like order of magnitude. I mean, nhist in MATLAB is, nhist in GNU plot is, I think in, what?
It's GNU plot, the plotting?
Well, if I get a complete call tree and timing, I'll tell you which it is, but I don't know.
Well, I gave you the function of the.
Yeah, but I need to track down the actual internal, because the thing I noticed is when I originally did that histogram of the levels, I did it in just a step-by-step by writing out, the histogram instead of using the call. And it took an hour to do a file. And then when I did it with their built-in function, it took about 1 minute and 20 seconds. And then when I tried it in MATLAB, it did it in about a second. So, you get what you pay for. But if you actually need to invert a 30 by 30 matrix, you can do that too. If you need to do least mean squares, loop closing for cave maps, you can do that because I wrote a program to do that. Problem with caving is that you think the measurements are accurate when you're laying on your back looking through an instrument with water dripping in your face. Not really. You don't really tend to be too accurate.
JJ,
Yeah.
could you work on bigger files by arbitrarily throwing away every so many samples?
Well, if the wave read worked properly in Octave, which it does in MATLAB, you could just march along the file and do an arbitrary length. But because wave read is supposed to be able to fetch a block at a time if you want. But that's only in theory with this particular version. I mean, with the wave read, it comes with MATLAB, which doesn't handle multi-channel very well at all. It does mono and stereo, and that's it. But you can you could just tell it, read one block, read another block, concatenate them, process it, read a block, concatenate, process. You could just stream. You could do a stream as for as long as you wanted. And if you put that through Simulink, you could even do it probably in real time. But this will take a little while because that is a long file.
So maybe this would be a good place to wrap up the library.
Sure. So anyhow, now you know where to edit the file. There's some other things in here. I can do that. Well, it won't hurt. It won't hurt to show you where to edit it while this is running. If you want to try different block lengths, there's your setting for block length. It has to be a power 2. If you want to change the sampling rate to 48, change this to 48. It won't really work for 96. You'd have to double the, well, if you double the block length, you can do 88 or 96. And then you really wait for a long time. But you can do that. Beyond here, just don't. You will get yourself into some deep, deep trouble if you try it. What?
There be dragons.
There be dragons, yes. I mean, if you speak MATLAB and you know how to do a psychoacoustic model, go ahead. But, it's from there on, it gets a little messy. I can show you, if you want, where you would put the, if you created an array, where's the FFT? If you created an array that moved the power outside this line, I did this for efficiency, otherwise you wait even longer. You could subtract the absolute threshold that you wanted to calculate from every bin of the FFT and then add the absolute threshold part in if you wanted. I'm not sure if you want to. I see a lot of blanks there.
Well, so can you explain absolute threshold? I don't know what you mean by that.
Absolute threshold of hearing is, you can hear.
Oh, okay.
Yeah, and absolute threshold of hearing varies by about 40 dB with respect to frequency. And especially, one of the things that probably you would see more dynamics in that Berlitz Requiem if I actually did the low frequencies right, because they're popping up and up above threshold and going back down, and I haven't actually with no absolute threshold, and I haven't actually included that. But
So I guess the thinking is that you would use your absolute threshold based on like Fletcher-Munson or something like that.
Well, you would just, well, I will make an observation. If you're listening, it depends on how you're listening to the things. If you're listening in headphones and you have closed both ends, you need to use Stevens. If you use loudspeakers, you need to use Fletcher. You notice the resonance, I might even have that backwards too, but if you notice the resonance, where the ear canal resonance shows up is an octave off for Stevens versus Fletcher. And one of them used sealed headphones and one of them used unsealed headphones. Hey, wait, imagine what happens when you close the other end of the pipe.
And the idea is that if it's below that threshold, you just throw it out.
No, what you do is you just subtract an energy equal to the value of the threshold from the energy of that line, which means you have to take real squared plus imaginary squared, minus that, and then take a minimum of 0, because there's no such thing as negative loudness. Besides which, if you take a negative number and you try to raise it to a power, you're going to wind up with an imaginary number, and that will propagate cheerfully through the rest of the program and leave you with the results that are best described by someone from another galaxy.
It's done.
It's done.
3 out of the 4 first part is done.
It is done. Okay, and the plot has started to show up over here. So let me get the plot over here.
Only one so far.
Yeah, well, the thing is, there's two histograms. This is the one that plots 5. So there are two of those bar histograms in here, and you are witnessing the blistering speed of how fast it plots the.
Oh, wait a minute, this one's missing the same codes.
For that same drop at 16, yeah.
Yeah.
Huh.
What's going on?
Your computer's missing the code.
But if you notice, some of the other ones don't. So.
Yeah.
Wow.
These two do. Interesting.
That's why it's free.
Where did you get these WAV files?
Off of the AC. So, you know. I'm just curious, though, that that's there. That could also be an issue with WaveRead, because there was a bugged version of WaveRead that had the wrong gain. So that one spike at half could be due to the version of WaveRead.
But you forgot to buy the 16K upgrade.
Buy. So this is Court of the Crimson King. And you notice that plot looks awfully, that plot of deltas looks awfully normal, doesn't it? As in normal distribution. There you go. But like you expect, it has quite a dynamic range, which is true of pretty much anything that Robert Fripp got his hands on, so that's not so surprising. If you try to do this on a desktop with 8 gig of memory, it's a lot faster, by the way. But there you have it. So with that, what? Bob is staring.
Why don't they remaster or reconvert or something, all this stuff? I mean, it's
Yes?
obviously it's what, in the 80s or something. Probably done in the 80s or bad.
Well, a lot of them have been, I mean,
Yeah.
Court of the Crimson King's been remastered.
Well, Court of the Crimson King was originally on tape, of course.
Yeah, well, there's no missing codes on the tape.
Yeah. Well, the thing is, toward the outer edge of the distribution, you expect to have some missing codes because it's just probabilistic that you won't hit them all. You know, if you look there.
If it's filtered properly, how can it go from one code?
Well, the thing is, if you look at it, you know, if that probability is down to 10 to the minus 9 there, and if you have less than 10 to the minus 9 samples, you're just going to have some zeros somewhere. That's just reality.
Oh, you think it's part of part?
It's just there's just not enough samples to hit the really unlikely samples.
Out at the end.
Out at the end, yeah. In the middle, if you got lots of zeros around 0, something is wrong. And I'm wondering if that spike is not in fact an artifact, because filed the bug on WaveRead 3 times, and 3 times somebody's fixed it, and then somebody else has come back and said, oh, no, no, it shouldn't be that way. I get rude, nasty emails from computer programmers that don't know anything about audio.
I mean, this is a long song, too.
Yes.
And so,
But, you know, still, it's not that many samples. We can look down here. It is, there are 46,000 blocks times 512.
well, that looks like those ones that are spaced right around sample 16,000 again.
That might be an artifact.
That's,
That might be an artifact of WaveRead, but I'm not going to. I'm not even going to try to track that down. The thing is, when you see lots and lots and lots of stuff like that, you got a problem.
that's probably 16,384.
It might be, or it might be 16,383. No, it might, seriously, because that was the problem. When they had the wrong scaling, that was in fact the codes that was missing. So, but it's interesting that doesn't show up in my home machine. But I fixed, but you know, but I've gone in and fixed WaveRead in my home machine. So that is WaveRead, and that doesn't show up in my home machine.
So when the poor unwashed of us are downloading things, which WaveRead are we getting?
I'll be getting that one.
So how do we get the one that's fixed?
You can go find it and email it to you.
Okay.
And you just write over the other one, because the other, it's only changing a scaling thing. Somebody doesn't understand quantization. Somebody that does linear algebra doesn't understand quantization. Can I tell you? So, with that, live long and prosper.
Live short and fester.